page 3 sees problem number 8 give us a product, and one of the parts of the product is a composite function. So this is going to be a product rule with a chain rule inside of it, and because we're asked for f prime. So here we go. Derive the first, the derivative of x minus 1. Well, that's nice. That's just 1, which we don't even have to write, but I will. And then keep the second. So x squared plus 2 all cubed. All right, and then product rule says plus. Now we reverse it, so we're going to keep the x minus 1, and we're going to derive the second term. And this is our chain rule. So the 3 comes out front, x squared plus 2, and that whole thing is squared. Students tend to forget this little square here. We don't want to do that. Remember, the 3 comes out front, all right, because we're using our, in essence, like a power rule. So the 3 is out front, and the new exponent is 1 less, squared. And we multiply this by the derivative of the inner function. And the derivative of x squared plus 2 is 2x. Okay, so there is our derivative, and it looks nothing like any of our 5 options. So we can see here that, yes, we have some calculus that we've done, but now we are responsible for some algebra and some algebra 2. So we've got to turn this into one of these. Every single one of these has a product, so that basically means that we need to get rid of the plus sign that's separating these two terms. In other words, we need to find a greatest common factor. First of all, we don't need that. So we see x squared plus 2 cubed, and this is x squared plus 2 squared. So we do have a common factor of x squared plus 2 squared, and we're going to need to factor that out. X squared plus 2 squared. And then we're going to write our leftovers in parentheses afterwards. All right, so x squared plus 2 cubed, but we divided out x squared plus 2 squared, which means we just have 1 x squared plus 2 left over. Plus, and then the x squared plus 2 squared, that's been out, so that's gone. Well, what's left? X minus 1, and then a 3, and then a 2x. All right, so there is the factorization. And now you see we have a product, just like everything up here. Right. Now we still don't have a match, but I think if we work on this second part, we're going to be in good shape. So what's going on here? Well, this 3 times 2x is really 6x. And when we distribute the 6x, that gives us 6x squared minus 6x. All right, and over here we have x squared plus 2, so we add those together. X squared plus 6x squared is 7x squared minus 6x plus 2. That's what this whole thing simplifies to. And it's also our answer for D. All right, number 9. H is a differentiable function, so we can take the derivative of h. And f is equal to h of the quantity x squared minus 3. Which of the following is equal to f prime of 2? Okay, so we have to get f prime. That means we have to derive this side, and we see h of an inner function. So this is a chain rule again. All right, so the biggest part of this problem is understanding that we're looking for a chain rule, where h is the outer, and the inner is our x squared minus 3. So f prime of x, derive the outer, h prime, with respect to the inner, x squared minus 3, times the derivative of the inner. And the derivative of x squared minus 3 is 2x. All right, so this is f prime of x. We want f prime of 2. So f prime of 2 will be h prime of 4 minus 3 times 4. 4 minus 3 is obviously 1, so that's h prime of 1, and we're multiplying that by 4. So f prime of 2 is the same thing as 4 times h prime of 1. And we see that over here with B. With number 10, we're given the graph of f, which is just 2 line segments. Here's the first one. There's the second one. G is 2x plus 1, and h is f of g of x. We have to find h prime of 1. All right, so we're getting into a lot of stuff here, but again, the key thing is this is the chain rule. We're asked about h prime, and h is a composite function. Now, when it comes time for f prime and g prime, well, that gets into our not only our derivative rules, but our idea of the slope of the tangent of the curve and everything. But let's check this out. First of all, let's just figure out what h prime of x is. So h prime of x, right? F is the outer, g is the inner. So derive the outer, with respect to the inner times the derivative of the inner. So there's our derivative of h. Now we want the derivative of h at 1. So this is f prime of g of 1 times g prime of 1. All right, now what's g of 1? Well, g of x, I'll go way over here, g of x is 2x plus 1, so g of 1 is obviously going to be 2 plus 1, or 3. So this is f prime of 3 times g prime of 1. Since we're working with g already over on the right, let's keep going. So g prime of x is the derivative of 2x plus 1, which is just 2. So g prime of anything, including 1, will also be 2. So we know that that's a 2. Now what about f prime of 3? Well, this is the graph of f, and we want the value of the derivative of f at x equals 3. Well, here's x equals 1, x equals 2, there's x equals 3. Now we don't want to use 0 because that's f of 3. We want f prime of 3. All right, so f prime of 3, the derivative of what we see, well, the derivative is the slope of the tangent to the curve. And our tangent is going to be right on the actual line itself. So we just need to find the slope of this line. Good thing they gave us the points just to verify it. All right, so we do a quick little slope change in y. So we have 4 and negative 2, so 4 minus negative 2, over the change in x, 1 minus 4. All right, so it looks like we have 6 in the numerator and negative 3 in the denominator, which simplifies to negative 2. So there's f prime of 3, and negative 2 times 2 is obviously negative 4, so the answer is A.